I am Dr. Neha, and today we'll be talking about thermoplastics and thermosetting polymers. So, these are the types of polymers, that is thermoplastic and thermosetting. They have been classified on the basis of temperature. They both show different behaviors when the temperature is applied on them, and thus they have been segregated differently. So, today we'll understand why the segregation is done. So, thermoplastics on daily basis we use polyethylene, and thermosettings on the daily basis we known as PET and bakelite. So what thermoplastics are? They are the soften, they are the polymers that soft on heating and harden on cooling. They can be reversed and repeatable, they can be recycled, and they can be melted and remolded again in the desired shape. They can be reshaped, recycled, and they are synthesized by addition polymerization reactions. The key characteristics of the thermoplastics are they do not undergo chemical change when heated. Changes are physical and reversible. They soften upon heating and harden upon cooling, can be remolded multiple times. Linear or branched molecular structure with no cross-linking is there, and they melt upon reheating without decomposition. They maintain their structures within the temperature limits. They are generally flexible and tough, with lower thermal resistance compared to thermosets. Now, they are soluble in some organic solvents. They are easily recyclable due to remolding capacity, and they're processed by methods like injection, model, and blow molding. Now, we'll discuss about some popular polysets, thermoplastics. First is polythene, which we use in daily life since a long, long time. It is the first polymer that was produced in the polymer industry. So the monomer is ethene. You can see this is an ethene molecule, and the reaction is addition polymerization reaction. So simply, ethene molecule is taken in free radical presence, and they polymerize together. Just add to form polyethylene or polyethene. The characteristics are they are lightweight and durable. They are chemically inert. They are resistant to moisture. They have good electrical insulation, flexible with good impact strength. They soften at relatively lower temperatures. They're easy to recycle. They are low cost and are easy to process. They are non-toxic and safe for food contact. The applications are they are used in packaging, that is plastic bags, cling films, and squeeze bottles. They use in household items like buckets, containers, toys, pipes and fittings, water and gas distribution. Normally we use high density polythene here. Electrical insulation for the coating of wires and cables. In agriculture, for mulch films, greenhouse covers. In medicine, that is bags, tubing, and automotive fuel tanks and bumpers in high density form. That means they are used in form of high density polythene. The second important polymer as thermoplastics is polypropylene. Monomer is propylene. Like polythene, they are also formed by the addition polymerization process. You can see over here, this double bond breaks and they further add together to form a chain-like structure in the presence of Ziegler-Natta catalyst. And the characteristics include they are lightweight and tough. They are high chemical resistant to acids, alkalis, and solvents. Excellent fatigue resistance. That means even if you put a lot of mechanical pressure, they will maintain their shape for some time. They have high melting point, suitable for hot fill applications. They have good insulation properties, electrical as well as thermal. They have moisture resistance and non-absorbent. They are semi-rigid and translucent, and they can be easily molded and recyclable. The applications include packaging, like food containers, bottle caps, and yogurt caps, used in textiles to make ropes, carpets, non-woven fabrics, then used in automotive, battery cases, bumpers, and interior trim parts, used in medical, as syringes, specimen containers, and medical vials, in household items as storage boxes, kitchenware, and plastic furniture, in industries, in pipings, fittings, and lab equipments, and stationery folders, files, and clipboards. Next is polyvinyl chloride, also popularly known as PVC. Its monomer is known as vinyl chloride. They're also formed by the synthesis of addition polymerization reaction. You can see in the presence of per acid, this vinyl chloride is getting polymerized into the polyvinyl chloride. Its characteristics include strong, rigid, and durable properties. It can be made flexible by adding plasticizers, Excellent chemical and weather resistance. They have flame retardant properties. They can extinguish themselves. And they have good electrical insulation properties. They are resistant to moisture, corrosion, and abrasion. They're easy to mold, weld, and bond, and they're available in transparent and colored forms. Their applications include construction. In construction, they are used as pipes, window frames, doors, and wall panels. In electrical industry, they are used as wire and cable insulation and switchgear housing. In medical, blood bags, IV tubing, oxygen masks, etc. are made of this PVC. As consumer goods like shower curtains, credit cards, and toys, we use PVC. PVC also used in clothing and accessories, synthetic leather, and raincoat belts. They're used in packaging of blister packs, shrink wraps, and cling films, and signage and banners, weatherproof boards, and advertisements. Now, we will talk about thermosetting polymers. These are the unique class of polymers that irreversibly hard when heated or cooled. Once set, they cannot be softened or remolded by heating due to the formation of three-dimensional cross-linked molecular structure. For example, bakelite, which is the most popular thermosetting polymer in the industry. The key characteristics of thermosets are they undergo thermal chemical change when heated. They form strong, infusible, and insoluble structures. They do not melt upon reheating. Instead, they may decompose on further heating. Typically, they are brittle but strong with high thermal and chemical resistance. Now, we'll study about bakelite, which is representation of thermosets in industry. The monomers of bakelite are phenol and formaldehyde. You can see over here. So, three steps bakelite is formed. The first step happens when phenol and formaldehyde they undergo condensation polymerization to form ortho para hydroxymethyl phenol, which is an intermediate. This intermediate keep on reacting with similar units to form a linear polymer known as novolac. This novolac linear polymer they undergo cross-linking to form this network-like structure, which we finally called as bakelite. It's a called cross-linked polymer, and this cross-linking actually is responsible for its high temperature resistance and brittleness. The characteristics include they have made with high electrical properties to include switches, sockets, plugs, and circuit breakers, insulators. They are used for making household items because of their flexibility, easily available, thus used in industry, radio communication, jewelry, accessories, and automotives. Their application includes insulation. They have high excellent insulating properties, thus we are using it into sockets and switches and wire insulation. Components in industry, it is used in manufacture of electrical switches, relays, and other parts in electrical system due to its low electrical conductivity and heat resistance. It is also used in motor parts for insulating plates and communicator segments. Also used in high frequency electronics as its low moisture absorption and good insulation make it ideal for such insulators. Also used in aerospace applications, that is, heat resistance and insulations are crucial, then the bakelite will be called for. Now we'll see a comparison between thermosetting polymers and thermosetting polymer. Thermoplastics get softened on heating and they get hardened on cooling. They are reversible, while thermosets are permanent hardened on heating and they're non-reversible. Here, there is no chemical change occurs during heating. Here, when the thermosets are heated, cross-linking occurs, so chemical changes are evident. Third difference is they are linear and branch chains, while thermosetting polymers are cross-linked, which is beyond branching, getting into three-dimensional structure. Now, fourth point will be thermoplastics can be recyclable and reusable. Thermosets are non-recyclable once they are set because they cannot change their structures again and be recycled. Thermoplastic polymers use temperature low to moderate, while thermosets they get high temperatures, but on very higher temperatures they may degrade instead of melting. Next, thermoplastics are generally less strong than thermosets. Thermosets are strong, rigid, and hard. Thermoplastics are flexible and ductile. Thermosets are brittle in nature. Thermoplastics can dissolve in certain solvents, while thermosets insoluble in most of the solvents. This is why they are most stable form of polymers. Examples popular of thermoplastic polymers are polyethylene, polypropylene, PVC, polystyrene, PET, nylon, and thermosetting polymers, bakelite, epoxy, melamine, and phenol formaldehyde. These are the references where you can find these topics in detail. Thank you.